All right, so we're gonna go over week 8 stuff, which is mostly about subqueries. So I kind of wanted to just real quick. Um, this should be the second time we go over subqueries, but we're gonna go over it in just a little bit more detail, specifically about some different operators. Um, which shouldn't be too crazy, but really I just kind of want to explain subqueries again at a fundamental level, and um, hopefully it makes more sense now that we've seen more select statements. We've hopefully with your final you've started creating some of your own stuff. So I'm hoping this week the subqueries will make a little bit more sense, and then it should be not too bad because really like this week it should be pretty light. But if we understand subqueries, that's what's going to make it easy. So I'm going to start just by kind of going over some of the fundamentals, and it might be something we've already talked about. So bear with me, but um, most likely someone's going to get something out of it. So what I'm going to do is I'm just going to do some examples right out of our database so we can kind of get some different ones. And I guess what we're going to talk about is in here, you can see like the reading objectives, how to write a single row subquery, returning only one column. Single row subqueries returning more than one column. We're gonna cover some of those, some of the different use cases, because then I think things will kind of make sense. So we're gonna dive in here. So the first one is probably the most simplest version. Um, so if I wanted to get there's in SQL, there's most of the times there's many ways to kind of go about skinning the cat. And so we've seen cases where we get all of our customers and how many movies they've rented, because we wanted to see which customers were the best for our business. I guess I want to use Sequila, type in what I say instead of what I need to. So we've gotten like how many customers and what movies they rented, and we did that with an inner join to rental, if you remember right. So I'm gonna just real quick get this here. We did that on c.customer ID is equal to r.customer ID. We used aggregation there. So we would get something like c dot first name, c dot last name, and then we got the count of c dot or of r dot customer ID as rental count, something like that. And we need our group by, obviously, because we're using a aggregate group by c dot first name and c dot last name. So this is one way we did it. We get our rental count, and I'm kind of a join person, and when we're talking about efficiency, you always want to use a join when possible, but there are times when we don't have that option. We've ran across those even in some of our own explanations here. For example, when we were doing our outer the type of joins that Oracle doesn't support, or not the type of joins, the set operators, like intersect and minus. We use those for some of those things, and we use subqueries for those. So I'm going to kind of go through those. We're going to look at some correlated subqueries, some of those, but I just want to start at the basics. And I think one of the most basic ways we can do it is actually just by pulling it in our select list. So because that's the thing about subqueries, is we can kind of use them wherever. And they all kind of can do different things. They're really, really handy. And sometimes you have to use them. So for example, we can get all of our customers. We get their first and last name. Need my alias. There we go. So we get their first and last name, just like we did before. But if for whatever reason we can't do a join, or we just don't want to, we can actually get the count of rental just by doing a subquery. And this is an example of a correlated subquery, because we're going to use something from the outer query in the inner query. So for example, let's just say I want the total count of rental in here. I can select the count of everything from rental. let's call it as rental count. Now, when I run this, everyone's going to have the same number of rentals, right? And that's a very basic, that's a single row subquery that returns one column. That's one of them. Now, if we want to correlate this, because really what we want is we want the count that's for that customer. So what we do is we say from rental where customer ID is equal to c dot customer ID. And all of a sudden we're correlating the outer query with the inner query, because now for every customer that we are looping through in this first query, it's going to run this select statement. Now you can see where efficiency becomes an issue, because instead of running one query, now we are asking the database to run one outer query, but for every record in the outer query. So for every customer, we're going to run an additional query individually. So it's far less efficient, but we can get the same result using a correlated subquery. So really, anytime we refer to a subquery, we're just pulling some information inside of an existing query. And we can use those in a lot of different ways. This is one of the best examples, I think, just to kind of get the point across. Is there anyone who wants me to explain this further? Does this make sense to everybody? What makes this a correlated subquery? The correlation comes in because we're using, before it was correlated, we just got all the rentals, but we want to correspond the count. We want to use something in our subquery from the outer query, which we can do, which is really handy. So does anyone have any questions about what we just did right there?
I do, about just the alias on where customer ID equals c dot customer ID.
Okay, yeah. So right here, and what I love about subqueries is until they're correlated, we can run them all by themselves. So if I wanted to run this all by itself without the where clause, I can just take it right out. We can paste it here and I can run this. We get the 1644 like we did the first time. And so really when we, because this customer ID where it doesn't have an alias, the compiler, the computer is smart enough to know, okay, this is part of this inner query and it doesn't have an alias. So it refers to rentals customer ID. Now, I try to keep things small, but really if it helps make sense, because on some of my more complicated ones, I'll be honest, I still use aliases. And sometimes I might have rental already in the outer query, and I have to use tables 2 or 3 times. So that's when I get into subquery 1 rental, if that makes any sense.
Yeah.
You can get really complicated. And maybe that helps you keep things organized. If this makes more sense to you, by all means do it, because then that way, okay, this customer ID is coming from here, where this customer ID is coming from the outside.
Okay. Yeah, that makes sense. Thank you.
Yeah. Good question. Yeah. So I try to keep it simple when I'm trying to save keystrokes, but oftentimes, and there gets a point where it's hard to keep track of aliases. And so it's easier to keep everything in the subquery as isolated as possible, because we have SR1 here, but if I tried to use SR1 right here, so if I say where S1R dot rental, rental date is equal to today, it wouldn't work, because it's kind of like a function in programming where, whatever's inside here is kind of isolated. We can use outside, we can use something from our outer query in the inside of the subquery, but we can't use anything from the subquery outside, if that makes sense. Only what it returns. And that's the key, is we can use whatever it returns. We just can't use its own components there. And it's a common ideology in programming, because essentially what this is, it's kind of like running a mini function in a way. It's isolated, it's by itself, and we can kind of pass in a parameter, but we can't access any of the variables inside there. We have to just use what it returns, and that's what it does. And so what it's going to return is the count from rental where the customer ID matches. So it's going to run its own query every time it goes through a row. So that's a single row, single column type of thing. So what I want to do another example of is a subquery where we return multiple rows, multiple columns, because I think that's always handy. And what I like to do is I like to use views as a good example, because I really, once you kind of get out there, if you're running your own, like if you're a DBA, most of the time, if you're using a subquery to kind of in this way, a lot of times you're just going to write a view, which is essentially the same thing, but it's a little different. So what I'm going to do is I'm actually going to pull, I'm going to make a query that's pretty common that we've done before, and it's the actors and the movies that are in. So I'm going to get the A dot first name and the A dot last name from actor A. There's our actors, and we're going to take that, we're going to interjoin that with film actor on A dot actor ID equals film actor dot actor ID, and then we're going to interjoin that with film F on FA dot film ID equals F dot film ID. All right, so now I'm just going to add our F dot title, I think is what it is. There it is. So pretty common kind of query that we would probably use pretty frequently in our database, like what actors are in what movies. So now we have that. Now let's say we want to know, like, okay, your boss comes to you and says, hey, we're trying to run a targeted email advertisement campaign. And what we want to do, he says, is we want to advertise movies to people that have their favorite actors in them, right? If you want someone to rent a movie, like, I'm a huge, I love Will Smith, right? So if someone sent me like a list of movies, like saying, hey, we're having a special on Will Smith, like let's say everyone got the same deal, right? But it was just for their favorite actor. You were having a deal and you can rent Will Smith movies for 50% off. I might be more inclined to do that because I have, I like watching Will Smith movies. So what we're going to do is we're going to use this subquery. And again, like most things, there's usually a way we could do this with joins. But what I'm going to do instead is we're going to use this subquery, and we're going to find rentals. We're going to find the people's rentals where, and based on the actor. So we're going to take and kind of combine these two together. So real quick, let's see, because we have our film, and then in rental, do we have a, let's see what's in rental. Is there a film ID in a rental? Select everything from rental. Let's just take a look, inventory. So we're going to go down this little rabbit hole. We're going to take a look at inventory. Okay, so we need to then join to inventory, which we'll do. So we're going to start here with this same select statement. I'm just going to copy it down here, because what we want is we want our customers and their rentals. We don't care about necessarily a count of rentals right now, but we're going to interjoin rental to inventory. I is what I'm going to call that one. We're going to do that on r dot inventory ID is equal to I dot inventory ID. And then we're going to interjoin that to film. F on I dot film ID is equal to F dot film ID. All right. So we kind of just are going to get a list of customers or rentals, and then what actors. And again, we could do a join here, but let's say for whatever reason we can't, or we just want to try doing it the hard way. So what I'm going to do is I'm just going to put this in parentheses, this whole query. And what's nice, like I said, what I like about subqueries is unless they're kind of correlated, you can run them all by themselves. So we had already ran that same query. We got all the actors and the film they're in. So we know exactly what it's going to consist of. And in this case, this is going to act like a temporary table. So I'm going to put as, I would say film actor, but that already exists, as actor film. We're just going to put that there. All right. So what we're going to do is we're actually going to join this. So I'm going to say interjoin And I'm actually going to add f dot film ID here. We're going to interjoin our select statement as actor film. And I don't think we really need actor film. This is where different databases act a little different. I think we don't need the as, but we're going to join there where f dot film ID is equal to actor film dot film ID. And I'm actually going to change this. We're going to call it subquery sub one. We're just going to call it sub one. So that way we can keep track of where the subquery data is coming from. So just like a normal table, we just did our inner join, but instead of joining to an actual table, we kind of created our own table that we are going to join to. So let's go ahead and see what we get here. And we want to add some data from there. So let's get sub one dot first name. That should be the actor first name. There we go. And let's just add a little bit here to make sure that it makes sense. So now we have all of the customers and then their rentals and then the actor's first name and last name. So at this point, we have like all the list of customers and the actors that are in the movies that they've rented. So from there, we could do all sorts of stuff. We could aggregate that. We could do whatever. And really, we could have gotten this just as easy by doing an inner join all the way to the actor and done it that way. But this is just to show you that we can essentially get the same thing through a subquery. Or you can use those in various different ways. In this case, we used it like a table, which can sometimes be handy. Sometimes you have to. It all just depends. But we can use it. And in this case, we're using a subquery that returns multiple rows and multiple columns, because really we can see exactly what this subquery returns by just running it, because it's not correlated. It's just there. So this is what this subquery returns. So when we run this query, it's actually taking this whole table and it's using it temporarily after it runs the whole query. And then from there, we use it just like a normal table in memory. Does that one make sense to everybody? Multiple rows, multiple columns. Basically, I wish that if I had to sum it up, when you see that, just say, oh, this returns a table, because what are multiple rows and what are multiple columns? It's a table. All right. So let's go over some in the where clause with the in any exists type thing. So sometimes, like again, if we're using our film, like let's say we wanted to just see actors in films where they had been rented. So in this case, we want to we have our query here that gets all the actors and the films they're in. We have their film ID, the title. Let's say we only want to see movies that had been rented. Now, again, we can do this with a join, but what we're going to do is we're going to use a where clause instead with a subquery. So what we're going to do is we're going to say where, in this case, it would be f dot film ID, and we could say in, what are some of those that we need to cover? In any all. Okay. In, and I'm going to say select, or let's say we want to see what are all of our, we want to see all the film and actor titles where the, where they've been rented. So what I'm going to do is I'm going to select film ID from inventory. Because if it's, and then we're going to interjoin rental R on I.film ID. No, not I.inventory ID is equal to R.inventory ID. So essentially what this query is going to return is the film IDs of every movie that's ever been rented. and how many times they've been rented. So it's going to return duplicates even. So it's going to return that list to this in clause. And remember, an in clause, normally we could have just a list. So we could say, you know, film ID 1, 2, 3, 6, and 8, where film ID in 1, 2, 3, 6, and 8. But we don't want to have to go look all that up. We want to kind of do it dynamically. So, you know, we want all the films that have been rented, and we're going to return that to the in clause. So we're going to get all that information for all the films that have been rented, which I think in our database, like every film's been rented, that sort of thing. Does anyone have any questions about that one?
Real quick,
Yeah.
if you were to do a count back when you had like just the numbers, you could count that.
Say that one more time. Like up.
In the query that you just did, at first you were showing just the inventory. Select film ID from inventory.
Yeah, and because basically what I'm showing here is like, because these are all the movies that have been rented, essentially.
Right.
And I don't go all the way to film because we don't necessarily need to, because we have the film ID.
Yeah.
If that makes sense.
Yeah. Thank you. Sorry.
Yep, no problem. All right, and there's a couple others like the any. So in this case, like if we wanted to kind of do an any, any's kind of similar. The only difference, like, so in kind of checks for in a list, where any is kind of like a true false thing. So for example, I could do any select film ID from film where title is like % Wyoming. Oh, and don't tell me that MySQL doesn't support that. Let's pull up that stuff. Oh, sorry. Let's see. So I'm missing. There we go. Okay. So the any is going to evaluate like a true or false. And we can pull like a lot of different things from here, and it's kind of weird. But anyways, the any operator will return true if the comparison is true for any of these. So for example, if you want to check to see if film ID is less than a whole list, you can do so. So film ID isn't a great thing here. Let's use our rental table. So let's say we want all of the actors from film where the F dot release year is greater than, and this is kind of hard because I don't know like the movies, but let's pretend that the movie Academy Dinosaur is, you know, something good. You know, I don't know, because normally when we do comparison, we like to check against one thing, like a singular date. You know, so like let's say we want to see everything where the release year is greater than 2015. Well, sometimes we want to check to see if the release year is greater than a list, because maybe we don't exactly know. Because a lot of writing SQL is about like, you know, I don't know which movie is the oldest. I don't know any of that, but I do know that all of the Wyoming movies, right? So we want to see if the release year is greater than any one of these. So let's select the F dot release year from film where title like Wyoming. So in this case, we can check to make sure that essentially if the release year of our film here is greater than any of these, any one of them, then it's going to return true. And in this case, it returns more than one row because I forgot the any operator. And that's kind of the point. So the any operator is the magic that lets you check against multiple, right? Because normally, just like what we saw, the subquery returned more than one row. And that's kind of the point because we want to check against a list. Normally, like if we want to say F dot release year is greater than, like I said, 2012 or whatever, but oftentimes we don't know exactly what that number is. So we use the any operator to check against the whole list, which in this case, we don't have any that's greater. Maybe they all came out the same year. That's the hard thing about like a sample database. Let's see if it's equal to, and there we go. So now we know that they're all the same year as the Wyoming movies. So I'd be willing to bet that most of the release years are pretty close to the same. Any, and so any will kind of check that if it as long as it's equal to at least one, then it works. It returns true and it will show the row. If you use the all operator, it has to be equal to all of them. So it's like the same thing. The only difference is it would be all. And then let's actually check and let's see what our results are from this. I'm just curious. Oh, and maybe that was our problem. Let's try this because that we were correlating that subquery, which is no good. Let's see if we still have this. Yeah, it looks like we might still get the same results. Yeah. Okay. So we're going to get the release year from film where the title's equal to Wyoming. So they're all 2006. So if we use the all operator here, it's going to be the same thing as just putting 2006 because they're all the same. But it would check against all of them. So, you know, these are kind of utility things where it's like if you want to make sure, you know, that all of your records are greater than a list of other things, then you could do that. So in checks is see if they're in a list, and that one's by far the most popular. Any is kind of there, and all is kind of there just for utility. So like if you wanted to make sure that, like, let's say we were checking for valedictorian, you know, we could run a real quick query to check to make sure that the valedictorian GPA is greater than all, select GPA from all students, kind of a thing. All right. Let me check to make sure we're not missing anything here. Oh, and exists. Exists is a good one. I'm trying to think if we have a good example in our database here. Let's see. Let's just try one with our Wyoming movies here. Let's see. Let's do. Just select the film ID. All right. So exists is kind of like it just checks to see if it's kind of weird. Let me let's see if I can pull up the official documentation because I think that will help make the most sense. The book probably does actually a pretty good job. Okay, there we go. All right, so the exist operator is again a Boolean, returns true or false, just like the all or any. And it tests for existence of rows, obviously, because it says exists. So let's see if they have a good example here. So here we have like our customers and orders. And the following statement uses the exist operator to find the customer who has at least one order. So really what we're doing is we're getting everything from customer, where exists, and basically we check to see, really all we do is we check the customer. So we can use our same query here. The only difference is we need to add our correlation. So that's kind of the key, is when you use the exist function, you need to use correlation to make sure, because obviously they all exist. So we need to use correlation to kind of match them. So what we're going to do is we're going to say where film ID is equal to film ID, just like we did kind of earlier where we kind of correlated that. So now we get all of our Wyoming movies. So where this one's kind of handy is if you just want to kind of limit things, you can, from a subquery, you just can make sure things exist. It's almost like an inner join in a way, but in a where clause fashion. And you're not matching rows, you're just kind of just checking to see if things exist, really. Just like in this case, we are going to, all of the Wyoming movies exist, obviously. And so we only want to return the actor information for the Wyoming movies that exist. So anyways, there's lots of different ways to skin a cat, really, which is kind of like I guess the whole idea of this. Subqueries are kind of like the magic stuff that, like, when you have to do something that isn't possible in best case scenarios, they're kind of so versatile that you can make a lot happen. So there's a lot you can do. Does anyone have any questions about subquery? Any specific example they want to see before I cover a couple of things about just some database design topics that have come up?
This week they had grouped some stuff together. So the example in the book. Wait, turn back there. I lost my page. So it's where they did select small fries, select average Joes, select heavy hitters, and then they put that grouping into a select query to then pull out that. So it's on page 177 of the book.
Okay. Let's see, where am I? I really need to get my book out of my drive here.
And it's under subqueries as data sources.
Okay.
And data fabrication.
Let me get logged into the book here. Let's see if I can remember my stuff here. All right. Oh, let's see. And this is in chapter 9, right?
Yes, chapter 9.
And what section was it under again?
It's under the subqueries as data sources.
Gotcha.
And then under data fabrication.
Yep. I'm glad you brought this up, because this is one of the best things to do. So I actually do this quite a bit.
Okay.
And I'm going to kind of use what I think is a little bit easier example.
Okay.
Just to kind of get the principle. because they have like a really nice like business scenario, but I'm gonna kind of pick one that I guess will just help you see like why they call it data fabrication, and why it's so useful. So
And the first thing that I'm trying to figure out is, so in here, the very first thing they said is payment underscore groups dot name. Like, but in the number 3 that we had to do for this week, assignment number 3, they did dot level. So like, what determines what, like, how are you supposed to know what you're supposed to put for that groups piece? If you could explain that piece as you're going through all this.
yeah, and they give like a very business like scenario. Like for example, if you were trying to, really what they're doing is they're fabricating some groups, right? And so we could do something very similar. So let's say that we want to group we want to build classification. Really what they're doing is they're building classification. So let's say we want to classify our customers by how many movies they rent, right? So let's say we're going to offer them discounts based on a tier system of how many movies they rent total, right? So like, oh, once you've rented so many movies, you'll get a discount. Now, like you said, what number to put there, like there's really no good answer depending. Like, so in our case, like what I'm going to do is I'm going to actually get the average. I'm going to get some counts. So I'm going to use our up here because we already wrote this one. So here's our number of rentals, right? So I can kind of see our, we range, and I'm going to order this by 3. So we start at 12 and we go all the way up to someone who's rented 46. So if we're trying to determine like what tiers we would want, I'm going to use something along those lines. So let's say if you've rented, the first discount comes at 15. Let's say 20, let's do 20, 30, and 40. So really what our ranges are going to be is we're going to say small fry because it's already on my head. We're going to say the small fry, which pays, well, let's just say normal. Let's not use what they're doing. So we're going to say the normal. So you're paying normal prices is from 0 to, what do we say? 20. So we're going to really say 0 to 19. On your 20th movie rental, you become tier 1. And that's from 20 to 29. Tier 2 is from 30 to 39. And then the maximum discount you get is at tier 3, and that's 39 and up. So greater than 39. And really we could summarize this one with less than 19. And greater. Yeah, whatever makes sense. So what we're going to do is, so we have our tiers set up. And so what we need to do now, we know that this data doesn't exist anywhere in our database, right? But we can fabricate this. And that's essentially what they're doing. So let's build our table, right? Let's build our fake table. So what we're going to do is we're going to first, let's build the first row so we can kind of see it. So we're going to say normal as name. So let's select normal as name. 0 as low limit. And let's use this. And let's say 19 as high limit. Right now I can just select this and I have that data. And so what we can do is we can kind of get clever and use our union all, and we can take and copy this same thing, because right now we get columns in one row. But what we're going to do is we're going to union all this a couple of times, and we are going to fabricate our data. So we have normal here. We have tier 1, tier 2, and tier 3. All right, and as our name, and we're going to change our limits. So this one's going to be our low limit for this one is 20, 30, and 40. And then our upper limit on this one's 19, 20 to 29, 30 to 39, and 40 to whatever. We're going to just, since we want to have something here, we're going to put 999 as the high limit. So I can run this, and now all of a sudden I have a table that's kind of, I like to say fake. It's fabricated. It doesn't exist anywhere. We kind of just made it out of nowhere. So now what we can do is we can take, because we have our tiers built in a little fake table, and we have our rental counts by customer. So if we want to find out, we want the first name and last name of our customer and the tier they're in. So what we can do is we can take this query here, this first one, and we're going to join it up with our second one. So I'm going to move that group by because we have to do our join here. So what we're going to do is we're going to say join, and we're going to make this a subquery, put those around it, and we're going to call this tier, and then I'm going to put my group by here. Now when we do our join, we want to join where so I'm just going to run this real quick, make sure we're still working. And then what we want to join on is we want it to where, because right now where we're doing just a plain old join, where we get a lot of different things. But what we want to do is we want to say where our shoot, I'm having a brain fart here. We want it to be where the count of their rentals is between the high and the low limit of our tier. And so what we're going to do is I'm actually going to show you a double whammy here with our without aggregation, just to kind of take the aggregation puzzle out of this. And we're going to use another subquery. I think this is a great example of where we can do that. So what we're going to do is we're going to get our customers and the tier first. Let's start there. So let's add our tier here. So tier.name. So you'll notice that now we have all of our customers. Let's take rental out of this equation too. So now we have all of our customers and they're cross-joined. In fact, I'm going to put this here. So we're using SQL 92. We're cross-joined with every tier. So Mary Smith has normal, tier 1, tier 2, and tier 3. So if we want to make this just nice and simple, we can say where, and this is where we're going to do our select the count of everything from rental, where customer ID is equal to c.customer ID. So now all of a sudden what we've done is we've selected the count from rental, so that's going to return a count, which doesn't make sense to our where clause because we need a condition. And this is where we say where the count of our customer in question is between tier dot low limit and tier dot high limit. And now you'll notice that Mary Smith only has one record and she's in tier 2. So just to kind of validate our results, to double check ourselves, what I'm going to do is I'm going to take this subquery and I'm actually going to put this subquery up in our select list so we can see how many movies they've rented as movies rented. And we're going to get the tier name. And then we're going to get tier dot low limit and tier dot high limit. And so now we can see, okay, Mary Smith has rented 32 movies. She's in tier 2 because she's between 30 and 39. So we can verify our results. Is 27 between 20 and 29. Yep. So she's in tier 1. Do we have any normals? Yep, we do. Here's a normal. He's rented 18 movies. So as soon as he's got to rent 2 more movies and he'll be in tier 1. Does that make sense?
That does make sense. Why did you choose to do name at the end of tier on the 4th line down?
Just so I had a name.
Okay.
You mean right? Let's see. Oh, right here.
Yep.
Okay, because right here in our subquery, subqueries, you kind of, if you're using subqueries as a data table, if you're using a subquery to return multiple rows, multiple columns, you have to have aliases for the most part, because if you plan on using them, for example, if I took out all these as clauses, I wouldn't have a name to pull that information. So the reason name is there is because really that's what it's named in my table, because tier, the tier table, which doesn't actually exist, this is what it looks like. And it has a column called name. So when I pull the name, I'm pulling, is it normal? Is it tier 1? Is it tier 2? Or is it tier 3? Does that make sense?
Yeah, it just, what was throwing me as I was following along with the example in the book, and they also used name, but I was struggling with this query for number 3. And when I looked at the answer at the back of the book, they used level. And so I was trying to figure out, why did they choose level over name?
Yeah, and you can kind of do whatever. I'm kind of a name person, because really to me, it all comes down to, like, because I'm an object oriented person. My whole career started in C++ doing object oriented programming. And so to me, whenever I look at a column in a table, it should be, in my opinion, an attribute of the object in question. So in this case, my object is a tier. Well, it's the tier name, right? And so that's where they get level. It's the tier level. So it kind of just depends on how you organize it, right? Like maybe there's different information in there. Like maybe it's a discount table and you have like a discount level, you know what I'm saying? So it kind of just depends on what your model is. I like to just have I like to have commonality. And so like, oh, what's the name of the tier? What's the name of the category? What's the name of the country? You know, those kind of things. So I like to keep it, because that way anyone coming into my database can kind of assume that if it's like an object, they can find the name of whatever it is, so to speak. So that's why if you see me whenever and like with certain objects like film, you know, films have titles. Films don't necessarily have names. So I kind of get those, but you'll often see me go to type film.name because it's almost habitual, because most of my objects have a name, if that makes sense.
I get it now, because in the example, they gave us the union piece of the query, and they used the word level instead of name.
Gotcha.
So the name, whatever you use after the as, has to match what's behind your tier.
Yeah, whatever your column name is. And so that's what I love about subqueries, is if you ever are confused. Now, correlated subqueries, those are the only things where we, you know, like for example, this one right here, we couldn't run this because we don't have c.customer ID inside this subquery. You know, it can't stand on its own 2 feet because it relies on the outer query, and that's what makes it correlated. But with most other subqueries, you can run them by themselves and see exactly what you're getting. So in this case, you know, we can run this and we can see, okay, you know, like the column name is name. You know, we're calling this whole thing here tier, like it was its own table. In fact, you know, just for kicks and giggles, we could say create table tier as, and now I actually have a tier table. Right. So that's what's cool about the data fabrication piece is sometimes it's often easier to fabricate your data than it is to do other things. So here's a prime example, and I wish I could show you with a real database. but like our schools have calendars, so like every day they might have multiple periods. So what I do is I can often fabricate the data because I will cross join the day. I have a table that has all the days in a school year in it, and I cross join that with a union thing of all of our periods. So like period 1, period 2, period 3, period 4, and I can cross join that, and then all of a sudden I have a table that has every day and every period. So then you can do lots of different things with it. So data fabrication with subqueries, and specifically with these unions, set operators, can be very powerful, very helpful. It can save you a lot of time. Like, if your employer came to you and said, hey, we want to categorize all of our customers into discount tiers, or even just for marketing, like these are our high priority, our tier 3 are our most valuable customers. This made it pretty easy. We had that done in just a matter of minutes, where it could be very difficult if you had to like export that to Excel, put in your equations, drag all the rows, it just gets weird. So it's really nice to do it this way because we can just get it done fast. So I hope that helped with that section of the book, because they're doing the exact same thing. The only difference is they're kind of doing it with some money. And I hope that this one helps because it should, it's one you can run, which I think helps. I mean, and I think that one, they have like payments in there too, but this one I think is a little bit easier to kind of wrap your head around. I'm not a money person, so whenever you add money, it's like, oh man, my head starts to hurt, but I can do this pretty easy. So.
Okay, can you explain one thing one more time? You just said it, where that line that says, the very bottom line where it says where select count from where customer ID equals, yeah, that piece. You said that could not stand on its own. You couldn't run it by itself and get an answer, right?
Yeah, because see, if I try to run this, it's gonna say that c.customer ID like doesn't exist. See, unknown column c.customer ID doesn't it doesn't know where it is. And that's because this is a query all by itself, but what makes it correlated is this thing is it's foreign to it. It doesn't belong here. We're actually pulling that in from outside.
Okay, so as long as you have defined what it is before, then you can use like c.customer ID within the query.
Yep, you can use things from the outside. I just remembered the word. In programming, it's called scope. So inside of this subquery, anything created inside of this subquery is limited to the scope of this subquery. So for example, rental, our query select count from rental, it only exists inside of this subquery. That's why we can use customer ID here without an alias, because the computer knows, hey, the scope of customer ID is it doesn't know anything else exists. So it automatically assumes that rental ID is the customer ID it's referring to. But we can use the outside in here. So anything created in here has to stay here. So whatever tables we pull from has to, it only exists within these two parentheses. But if we have something outside, we can pull it in and use it, because I like to think of it like the outside query owns the inside query, if that makes sense. Often like your boss knows information that you don't know, and man, you wish that they would tell you, but they only give you what they think you need. And in this case, we give the subquery c.customer ID to do its job, but it doesn't know any of the other information exists. The subquery doesn't. And we can't use any of the subquery information besides what it returns. Does that make sense?
So if it could have stood on its own, so this is called a correlated subquery. Let's see what.
Yeah, and it's correlated because it is connected to the outside query.
And it can't stand on its own.
Yep.
But if it could have stood on its own, would it then be known as a non-correlated subquery, or because?
Yeah, correct. Yeah, if we use a part of the outside query on the inside query to kind of connect them, then they're correlated. And the reason it's correlated is because if we took out this where clause part, everyone's going to have the same tier essentially. And that's because, well, and it's not going to return any because the total count from rental is, see, now this will stand on its own 2 feet, so to say. So we could run this by itself, right? We could say select count from rental. And it's going to return 16,044. So it's essentially the same thing as saying, my mouse did its weird thing. This is just like saying is 16,044 between the tier low limit and the tier high limit, which is why we don't get any rows returned. And so if we have a non-correlated subquery, it's going to be the same for every row in that table, essentially. But the minute we correlate it, we're going to say, hey, look at each row individually and correlate the two. So if we go back to where we were, where we have our where clause, now what we're doing is we're attaching the count from rental to the customer ID in question here. So essentially when the computer goes through here to decide where to connect tier, right? Because this is our tier data. It's going to say, okay, Mary Smith, how many movies do you individually have rented? Because this subquery is going to return 32. And so 32, is it between the low and the high limit of what? Well, tier 2. So that's what it attaches it to. And so on and so forth. So if we didn't have a correlated subquery, these would all be the same number, essentially.
When any part of the query is dependent upon the outside of the query, that is correlated. But if each piece of the query can stand on its own, then the whole entire query is now non-correlated.
Yeah, the subquery. Because really, like if you're asking, because really what we're doing is we're asking the computer to look at each person, how many movies they've rented, right? That's what this subquery returns is how many movies has, or how many rentals has Mary Smith had? How many rentals has Patricia Johnson had? And if we do that, if we single down to our row, because this is all dynamic, right? Like let's say all of a sudden we get 20 new customers added to our database. We don't have to change this query, it's going to pull them. So it's all dependent on the outer query, because the outer query is pulling all of our customers regardless of whether they've had rentals or not. So it's pulling all the customers, but the inner query is going to pull that how many movies each person's rented. So therefore it's tied. It's going to be different for every person because we said, look, correlate the two. We want you to match customer ID from the outside with customer ID in our subquery. It's going to run this every time it gets to a new person. And that's what makes it correlated.
So, and then just one more thing. So in that statement where select count from rental, where customer ID equals C customer ID. So because you said the word rental, you didn't need to put an R in front of after that where customer ID?
Yeah, because it's the only table we're pulling from.
Okay.
Then the computer knows, hey, customer ID exists in rental and it's not ambiguous. Like it only exists in rental because we only pull from one table in the scope of this subquery. So it knows you don't need it. Yeah.
Okay. Thank you for explaining all of that. I get it now.
Okay. Alrighty. Well, I will leave it at that unless someone else has any other questions, but my wife Taylor has to get to activity day. So I'm going to leave it at that. If you have any questions, shoot me a note. Hopefully this helped. Obviously playing around with it always helps too. So if you're playing around with it and coming to across any questions, let me know. If you have any questions about your final project, we didn't have time to get to some of those design concepts. So we'll cover that next week. If you have any questions with your design stuff, just let me know.